Okay, so I share my screen now. Okay. Can you see my screen? Okay. So let's begin. So the FIP topic that I do is about a multi-legged robot, so-called a Hexapod, that used for doing some outdoor patrolling or rescuing. So this project that I do with the Wave Technology Hong Kong company is an industrial project, and so I begin in this semester B. So this is the progress report for now. So in this presentation, I will do something about, first I'll introduce my schedule, that what I have done in the previous week and month. And then second, I'll talk about the system diagram of my robot. And then later on, I'll talk about why I choose Hexapod as the multi-legged robot that I use for the project. And then I'll talk about some of my progress, mainly for the hardware design, and I show some photo and testing video about what I do in the previous month. And at last, I will talk about what the further development in my next few months after this progress report. So let's begin. So you can see this is the schedule. So currently we are in semester B around week 13. So for now, I think I finished most of my progress that I do in semester B. I have finished the frame design, and all the background research have also been done. And also I have a little bit overwhelmed to the semester A already. I have did part of the hardware design. So I think the progress is quite satisfactory. So I should have enough time to finish all the project at last. Okay, then move on. This is the system diagram of the robot, the multi-legged robot that I made. So actually it separated to two main parts. The right hand side part that covered by blue color is the main robot, the system of the robot, and the left hand side is about the server side, the cloud server side that receives the data that feedback by the robot. So let's go through in the right hand side first. The main system of the robot actually separated into two systems. First, you can see the MCU. The MCU is mean the control unit of the robot. So it controls how the movement of the robot, and it is control the movement of the robot. And for the SBC, the single boarded computer on top, is used to collect and analyze the data that received by the sensors of the robot. So by integrating these two system units, it creates the main system of the robot. So and also apart from this, you can see that have some the power in. The DC-DC converter is used to provide a stable operating voltage for both of the units so that they can perform well. And then for the MCU part, you can see it connected to a servo controller so that the MCU can control the movement of the, for example, the next servo and the camera servo by using the PWM signal. And for the single board computer, it will use the serial communication to different kind of sensors, for example, the IMU ultrasound, so that it can perform some obstacle detection and know the position of the and the state of the robot itself now. And also it can connect it to the digital camera with the video signal, so that for the ultimate goal, it can perform some more advanced technology, for example, the SLAM technology, so it can finally become autonomous patrolling robot. So this is the goal of the project. And for the server side, you can see that it's a cloud server and connected to the robot by a USB Wi-Fi adapter. My plan for the communication is to use a 2.4 GHz Wi-Fi adapter, so that the data can be fed back to the cloud server and be at the server side. For example, the controller, the administrator in the server side can use a controller to control the movement of the robot. And I think it should be enough because 2.4 GHz Wi-Fi can have up to 50 meter in outdoor. So I think for now it is enough for the working. So move on to the next page. So what is yes, Yes. Okay. The initial measurement unit is have to measure the acceleration and measure the angle of the robot. So for the robot can know the position, how far he move, and the rotation angle of the robot, so it can like perform a steady state. Okay. And then okay, move on. This is the hexapod. So let's explain what is a hexapod. Hex have a meaning of 6 in the number. So actually the robot that is my screen covered the robot. Okay. So it means that it's a robot that with 6 legs. So with 6 legs, it means that the robot actually can carry more weight compared to other other multi-leg robot, for example, a 4-leg robot. So it actually have more weight capacitance compared to the others. And the second, the most important advantage is that it can really have a good ability to adapt to some terrain and irregular surface. So it is very suitable for doing some outdoor rescuing, for example, in some countryside. So the special design of the neck makes them can adapt to some irregular surface. And then the next one is that is omnidirectional. So each neck of the hexapod actually make up of 3 servos. So by integrating them actually can provide up to 6 degrees of freedom. So that actually the robot can be easily tuned to go to what direction it wants to go. And the last is the stability of the operating. The movement of the robot actually is called tripod gate theory. So what is the tripod? It's usually we can see is the camera tripod stand. You can see that is a very common technology that we use in our life, so it can provide a very stable standing. And for this robot, we also use this kind of technology when moving, so it can provide a very stable static standing. And also, even if some of the legs are, like for example, damaged or not workable, it can still support the whole robot working. So I think it is very suitable for doing some very harsh tasks in harsh environment. So that's why I choose using Hexapod as the multi-leg robot to design. Okay, so next page is about mainly the progress about what I have to. So in the first semester, to begin with a robot project, so first I have to have a robot first. So I mainly focus on the hardware design. And the hardware design, what is have is first is the frame of the robot, how it carry the next and how it carry the electronic components. And then the next is how the control unit, how I can control the robot. So this is the main 2 things I did in this semester. So first move on. What's the frame design? The frame design separates to 2 parts. First is the body frame that carry the electronic components, and then the second part is the leg segments. The leg segments also separate into 3 parts. First is the tibia, femur, and corsor. And I will talk about what the usage of them later. So okay, so first talk about the body frame. The body frame actually is made by acrylic board and I use a laser cut to cut it. So you can see that this is the shape of the board, and you can see the hole in the center. It is actually for mounting the control unit. So I can use the screw and nuts, then I can mount the control unit at the center. And from the 6 pairs of holes in the side is used for mounting the leg segments, so that the body frame can, and I have to mention that acrylic board is thick about 8 mm, so I think it is very stable and it won't be broken easily, even when have any some stress test or some unexpected situation. So overall, it's quite a stable body frame. And then move to the next part is the neck segment. So the idea of the neck design is actually come from insect neck. So although insects may have a lot of many parts, but there is the three most important. First is the courser, the femur, and the tibia. By connecting these three parts, actually it can perform well the function of an insect neck can do. So the next segment of my robot is containing 3 joints and 3 links per neck segment. So you can see the graph at the right hand side. It shows that by combining the joints and the links, it can provide a 3-dimensional movement. This one shows the rotational angle of each, and this arrow shows that the direction of the link and joint can go. You can see it can cover actually the 3-dimension. And for the material or the parts that used for the joint, actually I use a servo. It have to be movable so I can control the link. And the servo I choose is the MG996R. I'll explain why I choose this servo later. And for the link part, I try to use the 3D printed material. The 3D printed parts for using the link, and overall is the performance is still good, quite good, so it can perform the actual performance of the leg. So let's move. Why I choose this servo? Among the servo I've searched, this servo actually is the most cost effective. It has a steady weight of about 55 grams, but it can provide up to 15 kg torque when it's around 7.2 V voltage, operating voltage. And the cost is actually very quite low. It costs around 20 to 30 Hong Kong dollar per servo. So I have 18 servo in my robot, so it costs just around 200 HK dollar. I think this still this is still this price is still suitable for student for a project that do the robot. It won't out of the cost. And then move on to the next segment. What's the courser? The courser actually is the first next segment. It is used to connect the servo of the servo that mounted between the body frame and between the femur. So the main usage of this joint is to perform the rotation of the robot. This help you to turn to do the rotation. For example, how to move the robot forward, turn the neck forward. This is the usage of the courser. And then the next segment is the femur. This is the second segment of the leg. It acts as a bridge between the courser and tibia. The usage of this is to help the robot to raise up the leg so that it can perform any rotation movement. And then the final part is the tibia. The tibia actually is the part that direct connect to the ground. So it's the strongest and the thickest part I have printed for the parts in my robot. So it can provide a steady support for standing. And overall, this I think this is all for the frame part. Then next on, I move on to the control unit. So this is the board I draw for the controlling the robot. You can see that here have a lot of part. All the part is for the servo. And then you have see this USB adapter. This is for the communication between the SBC and the board, and also provide the power supply to the MCU unit. And then you can see that here have a XT90 power supply port. Is to provide the isolated power supply for the servo so that it won't affect the system unit. And then you can see here also have 3 kind of IC. It's like another crucial item for the board to perform the servo control, and I will talk about it later. So the main task of the control unit is servo control is so obvious, but for my robot it has about at least 18 servos to control. So for the chips MCU I use on the board, the STM32F103, it only provides 4 PWM channel. so I cannot control all the servo. So how to solve it? I plan to use a demultiplexer so that each PWM channel can provide up to more control for servos. And for the power supply, after several testing, I found out that the 72V is the most suitable operating voltage, that it can provide enough torque power for the servo, and so that the servo can walk and stand steadily. And I've mentioned that I choose the demultiplexer for multiple servos control. So the part number I choose is the CT74HCT23XM96. It's a demultiplexer that made by the microchip technology. So each demultiplexer can provide up to 8 servo controls. And the reason I choose it is that it has a relatively low propagation delay, only 13 nanoseconds, so that it won't affect too much to the signal transmit when I'm doing some control. And also the operating voltage is around 2V to 6V, so which matches my system voltage. My SVC use 5V and my MC use 3.3V, so both of it can provide the voltage for the MC to the multiplexer IC. I saw a little bit laggy though. Okay, so here's some of the testing video of my robot. So for now the controlling is not done, it's still fabricating, so it cannot perform walking, but in the video you can see that it can perform a very steady standing. Yes, it's one of the testing that I've do in the previous month. So it can, at least the servo itself can support the standing of the robot, and is stable. When I do some impact testing, it won't fall down. And then I think that's overall all of my progress have done that in the semester B. So I'll talk about what I have to do next. The next most important, of course, is how I can move the servo leg. So I have to do some programming for the servo controller. But before that, I first have to do solve some mathematical equations for the model of the robot. This is called the simulation of inverse kinematic model. So what is inverse kinematic is actually a theory that help you to find out how the robot move from one pose to another pose. So from a pose to another pose, you have to it helps you to find out how the rotation angle of the servo. So I have to build up this model in MATLAB first, so that I can find out actually how my robot have to program that in order to move to certain pose and direction. And then after finishing these two, and I can do some testing in the movement. So it is the working schedule in the next few months. Currently it's in examination, and the power unit is not yet finished, but I think after examination I can finish it. And in the next month, and I will continue the movement, the control of the movement of the robot. And I think, yeah, that's all of my presentation. Thank you. Yes. Yes. Yes, because for the robot, I have to first tune the angle of the servo first. So actually, the servo is being powered up to the initial position, so it can stand up. Yes. 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 Yeah, each demultiplexer. So in my board, I choose 3 demultiplexer. I use 3 demultiplexer. So by using the combination of the logic, so it can control a lot of up to 24 for now in my board. Yeah. Yes. Yes. Yeah. Yes. Yes. ARM program. Yes. Control it. Yes. Hmm. Yes. Hmm. I think no need, not sequential. It is little bit sequential, but the delay second is very low, so you won't see the big difference in the program. I think very low, so I think won't see much difference. Yeah. Yes. 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 Uh, yes. First, as I mentioned that the robot have to move in a tripod way. So actually, every time it moves, it have 3 legs as a standing support. So in my theory, so the walking, you first have to move up uh, each side 2 leg move up first, and then it turns to the stair up side, and then after the 2 legs are attached to the upper stair, and one of the last leg is attached to the downward stairs. Then the another leg can move to the upper stair. So every time it moves, have 3 standing legs. I think this one make to the fall to the robot, and it is actually every time it walk, it's all still contented to a very stable surface. I think maybe this little bit uh, a little bit too theory, but I think it's with the standing. Every time it have a 3 leg standing, so I think it won't cause falling because it is very stable. 3 leg standing is there. Yes. Mm. Yes. Yes. Mm. Yes. Mm. Mm. Yes. Yes. Yeah. Yes. It's not automatic for that. I think I can for some very difficult terrain. I can just change the operating mode of the leg so that instead of moving that far, actually, it first have to uh, so it can can have a more precise control in that operating mode so that the neck can well, for example, can be operated one by one in order to achieve some very difficult terrain. I think is one of the solution. And other is that uh, for now I don't have, but I may have some, for example, some pressure sensor or some camera for me to find out that whether the the environment of the terrain, so that it can determine whether the lake will be stable standard on the area. Hmm. Yes, 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 yes. Hmm. Yes, yes. Hmm. So for the ultrasound is obvious, it's just a simple sending a wave to the obstacle and feedback. So for that you can know the distance between the robot and the obstacle. So it can help you to determine whether the robot should go through the, so how long it takes for the robot to go to the obstacle. So it have to, when it have to wait after that, it can give you the information of that. And for the digital camera is also, it can help you to observe the routes of the robot it moves. So for example, it can, for I think the robot can move in the terrain surface obviously, but if it has a route that can avoid the obstacle, so why not? So the digital camera can help you find out whether it's the most suitable path for you. And it can also, camera, it can help you to analyze the environment. For example, you can, whether can you have to recognize any like human activity or when doing some rescuing and patrolling. Yes. It's not yet now. That one is not now, but I have to see the progress whether I can finish that. But I think hmm, memory for the single camera. Yeah, I hmm, yes. So I'm thinking whether I can try to use the solution of, I have the image, but I feedback the image back to the server. It help me to do the analyze, and it feedback to the robot. Is it possible? I think I have this kind of idea. So the single computer collect all the data and may do some like simple analysis. But if it is the video for the photo is too large, I think maybe it can pass back to the server side to do the results, and then it pass back through to the single board computer to do the instructions. Mm. Yeah, that delay. Yes. Mm. Oh yeah, you can see. Yeah, yeah. This I said it use a controller. Although I can also write a GUI for in a PC for controlling. But I think controlling a robot use the controller is the efficient one, the most efficient. A lot of, for example, the drone the wireless chip is also used the controller. I think by inputting a suitable command, it can achieve the movement. Yes. So I have to set up a few mode, the control mode for example, like for example, a mode that let you do some turning and walking, and then by changing the mode, it can select the leg that I want to control. So yeah, so I can change the mode, and I can use the mode that can help, let me to control the leg individually. Oh, I think yeah, mobile app is actually okay. I think yeah, mobile app is okay. If I use the 2.4 gigahertz, then mobile is absolutely one of the like the solution for the controller. Yeah. Hmm. Yeah. Okay, I understand. Yes. Hmm. Hmm. Okay, so no, so maybe the apps is uh another solution for this. Okay, thank you. Hmm. Yes. Yes. Okay. Okay. Uh, I think that's all. Okay. Yes. Hmm. What you mean particular application? Hmm. Yes. 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 I think this robot is for the outdoor rescue and patrol. I think it's one of the mission of it is actually the ultimate goal for it is to help to search some like for search for saving life. I think it can carry some emergency stuff, for example, some bandage or medicine that can carry uh, to the rescuer. So the goal is to actually have multiple of this kind of robot that put it into the countryside. So whenever some incident happens, so like for example last month, some people drop down from the mountain and it's climbing. So it takes a lot of time to for the searching team to search it. So I think placing some of this robot in there can help to increase the efficiency of searching and also can provide support to the rescuer. Hmm. Hmm. Yes. Oh, payload. Yeah. Okay. So I've mentioned mentioned back the like the loading of the each like the total loading of the robot. I think is good. Thank you. Okay. Hmm. Okay. Hmm. Too heavy. Yes. Hmm. Okay. Hmm. Okay. Hmm. Okay. Thank you. Okay. Okay. Thank you. Bye. Bye.